Hello dear students, how are you doing? I'm very fine. Today we are going to see infinite series. Infinite series. After revising this lesson, you should be able to determine whether a series converges or diverges. Second, you are expected to compute sum of infinite series. So now let's proceed to the lesson. Now let's see this one. Let an be a sequence and Sn be the sum of n terms of this sequence. As n goes to infinity, if Sn goes to S, where S is a finite real number, where S is a finite unique number, then we say that this infinite series converges. Otherwise, it diverges. Otherwise, if S does not exist, it diverges. So, now let's see example for this. Determine whether the following series converges or diverges. Now let's start from the first one. The sum of to the power of n, where n starts from 1 up to infinity. So the sum of to the power of n when n starts from 1 up to infinity is written in this form. The first term is this 2 the power of 1, it is 2 plus 4 plus, it goes on like this. When you see this, it is a geometric sequence with first term is 2 and the common ratio, if you take ratio 4 over 2 it is 2, 8 over 4 it is 2, and so on. So it is a geometric sequence with first term 2 and common ratio 2. So the sum will be evaluated in this form. Sn applying the formula G1 times R raised to n minus 1 over R minus 1. So this is equivalent to Sn is equal to G1 is 2, R is also it is 2 to the power of n minus 1 over 2 minus 1. So this implies Sn is equal to the power of, when you multiply these two, it is to the power of n plus 1. You can add the exponent to the power of n plus 1. 2 times 1 it is 2 over 1. So this will be the answer. So the limit of this sequence as n goes to infinity, the limit of this sum as n goes to infinity is this to the power of infinity minus 2, almost it goes on infinity. So we didn't find a finite number, unique finite number as n goes to infinity. So this sequence diverges. So hence the series diverges. Now let's see another example. This one, negative 1 the power of n, where n starts from 1 up to infinity. This one, the first term is this minus 1, second term square it is positive 1, minus 1, positive 1, it goes on like this. So when you add this, you get 0 if the number of terms are even. If you take, for example, if the terms are 2, cancelled out, the answer will be 0. If you take the term 4 terms, these two cancel, these two, and so on. So this sum is 0 when n is even, and minus 1 when n is odd. Therefore, as n goes to infinity, the sum will goes to either to 0 or minus 1. So it doesn't go to unique number. Therefore, this sequence also diverges. Since Sn does not approach to a unique number. As n goes to infinity. Hence, the series diverges. Now, the third example is this 1 over 2 the power of n, the sum of this, where n starts from 1 up to infinity. So this is equal to, when you put 1 here, you get 1 over 2, and second term it is 1 over 4, 1 over 8, it goes on like this. So this is it is a geometric sequence with the first term is 1 over 2 and the common ratio is also 1 over 2. So I can find the sum. or nth partial sum. The nth partial sum of this sequence is its Sn is equal to g1, it is 1 over 2 times r raised to n, it is 1 over 2 to the power of n, minus 1 over r minus 1. So when you evaluate this, you get this one, 1 minus 1 over 2 the power of n. So this is the nth partial sum. When n goes to infinity, this sum becomes 1 over 2 the power of n. So I can write here, this is 1 minus 1 over 2 to the power of n. So when n goes to infinity, this becomes infinity. 1 divided by a very big number goes to 0. So 1 minus 0, it is 1. So this sequence converges to 1 as n goes to infinity, Sn goes to 1. Therefore, since it converges to a unique number, hence the sequence converges. Okay, so let's proceed to the other part. This one, we are asked to determine whether this sequence diverges or converges. So 2n minus 1, where n starts from 1 up to infinity. This means when you put 1 here, 2 times 1 is 2 minus 1, 1 plus 3, and it goes on like this. So when you see this sequence, it is an arithmetic sequence with first term is 1 and the common difference, it increased by 2. So the common difference is 2. So the nth partial sum is given by using the arithmetic formula, sum of arithmetic progression formula, Sn is equal to this one. So putting the numbers, Sn is equal to n over 2 twice of a1. a1 is this 1 twice of a1 plus n minus 1. The common difference, it is 2. Therefore, when you simplify this, you get this one, Sn, n over 2 times 2n, n squared. The answer will be this, Sn is n squared. So as n goes to infinity, n squared also goes to infinity. So Sn goes to infinity. As n goes to infinity, Sn goes to infinity. Since we didn't get a finite unique number, this series also diverges. Therefore, as n goes to infinity, Sn also goes to infinity. So the series diverges. Okay, now let's continue to the other part. Let's see this one. If Gn is a geometric series with common ratio r, then Sn is given by this formula. We said this earlier. Now I can write this in this form. Sn is equal to g1 times r raised to n over r minus 1 minus g1 over r minus 1. But for r is between 1 and negative 1, r raised to n goes to 0. Look, let's take 1 over 2. If you take 1 over 2, we have seen this earlier, 1 over 2 to the power of n. When n goes to infinity, this goes to this. When n goes to, let's take the limit of this one. The limit, when n goes to infinity of this term, it goes to 0. Therefore, here, if r is a fractional number, r is, or that I mean, it's a number between negative 1 and 1. So r to the power of n will go to 0 when n goes to infinity. Therefore, from this, for n goes to infinity, this becomes 0. So this part becomes 0 for when n goes to infinity. So the remaining part is only this part. It is minus g1 over r minus 1. So taking minus to the denominator part and multiplying it, you get g1 over 1 minus r. So this Scn will go to g1 over 1 minus r as n goes to infinity. So finally, you will have this formula. It is the sum of infinite term of a series is given by g1 over 1 minus r, where r is absolute value of r less than 1, or r must be between -1 and 1. It is only for this case we apply this formula. Otherwise, we can't. It diverges. The sequence will diverge in that case. So now let's see example for this part. Evaluate this 1 minus 3 over 5 plus 9 over 25 minus 27 over 105 plus, and it goes on. You are asked to find infinite term of this series. So to find that, we need to find first G1. G1, the first term is 1. And the common ratio, when you take the common ratio, you get it is -3 over 5. Since -3 over 5 is between -1 and 1, you can apply this formula. The formula is infinite sum of the series is given by G1 over 1 minus R. So putting the numbers in the formula, the infinite sum will be this G1 is this 1 over 1 minus the common ratio. Here it is -3 over 5. So this becomes plus. You get this result. Is equal to, it is S infinite is equal to 1 over the sum of this, it is 8 over 5. When you divide this, you get 5 over 8. So infinite sum of this series, it is 5 over 8. Now let's continue to another example. Example 2. Okay, you are asked to evaluate this one. Cos 60 degree plus cos square 60 degree, cos cube 60 degree. It goes on like this. So to find this infinite sum, first we need to see the terms of this series. Okay, so since you know this, cos 60 is 1 over 2. Cos 60 is 1 over 2. This means 1 over 2 plus 1 over 2 squared plus 1 over 2 cubed, and it goes on like this. Therefore, this is equal to 1 over 2 plus 1 over 4 plus 1 over 8, and it goes on. So this is a geometric series with the first term is 1 over 2 and the common ratio is also 1 over 2. So you can apply the formula S infinite is equal to G1 over 1 minus R. So applying this formula, you will have this. S infinite is equal to the first term is this 1 over 2 over 1 minus the common ratio is 1 over 2. So simplifying this, you will have this one. This 1 over 2. 1 minus 1 over 2 is 1 over 2. When you take the ratio, you will get 1. This is the answer. Now let's continue to the third example. The third example is this one. Find the sum of the series, or the sum of this is equal to how much. So let's try to find this. So here the sum of -4 times 3 over 4 the power of n minus 1, n start from 1 up to infinity. This is equal to, using summation property, you can take out -4 outside from the sum notation, summation notation. So this is equal to this -4 into the summation of 3 over 4 the power of n minus 1, n starts from 1 up to infinity. So this is equal to, this -4 is factored out. So to this sum means the first term, when you put 1 here, 1 minus 1 is 0. This 3 over 4 the power of 0 is 1. So 1 plus 2 minus 1 is 1. 3 over 4 the power of 1 is 3 over 4 plus, it goes on like this, 1 plus 3 over 4 plus 9 over 16 plus, and so on. So when you see this part, it is a geometric series with first term is 1, and the common ratio, when you take the ratio of these two, it is 3 over 4. The ratio of these two also gives you 3 over 4. Therefore, it is common ratio is 3 over 4. The first term is 1. So the answer will be this. It is -4 times infinite sum is given by S infinite is G1 over 1 minus R. So G1 is 1 over 1 minus R is this 3 over 4. So that's it. Now simplifying this, you get this answer. This is equal to -4 times 1 over, this is 1 over 4. So taking the reciprocal of this, multiplying by -4, you get -16. The answer it is -16. Let's continue to the other example. Example 4. This question is given. The sum of 5 the power of k r, where k starts from 1 up to infinity is given to be 1 over 4. So you are asked to find the value of r. You are asked to find the value of r. So from this, look this one. Summation of this means it is 5 to the power of, when you put 1, it is 5 to the power of r. When you put 2 on place of k, 5 to the power of 2r plus 5 to the power of 3r plus, it goes on. And the result is given to be this 1 over 4. So from this you can see that this is a geometric, it is a geometric series with the first term is 5 to the power of r. With a common ratio, if you take the ratio of the two, you get 5 to the power of r. First term, 5 to the power of r. And the common ratio is also, it is 5 to the power of r. And the sum converges. Since the sum converges, we can apply the formula S infinite is equal to g1 over 1 minus r. Using that formula, you have this one. g1 is 5 to the power of r over 1 minus r is also, we say it is 5 to the power of r. This result is equal to 1 over 4. So solving this, we will find the value of r. So multiplying, cross multiplying, it's 4 by 5 to the power of r and 1 by this, you get this one. Take minus 5 to the power of r to this side, you will have this one. When you take this, it becomes 4 times 5 to the power of r plus 5 to the power of r. So this means it is 4 5 to the power of r and 1 5 to the power of r means it is 5 the power of 5 times 5 to the power of r. The product of the two, it is 5 to the power of r plus 1. 5 to the power of r plus 1 is equal to, it is 1. From this means I can write this 5 in the form of 5 to the power of 0. So this implies that r plus 1 is, it is 0. Therefore, it is r plus 1 is 0. So the final answer will be this, r is equal to negative 1. Okay, the fifth example is this one. Let's see this. A ball is dropped from a height of 100 meter. It's dropped from a height of 100 meter. It's dropped from 100 meter above flat surface. And in each bounce, it rebounds 75% of the distance it fell. So you are asked to find the total vertical distance covered by the ball before coming to rest. Look, let's see this graphically or pictorially. A ball, assume this is a flat surface. A ball is dropped from this height. This height is, it is 100 meter. So, and it rebounds. So it rebounds to the height of 75% or 3/4 of 100. It rebounds that much height. Therefore, this height is, it is 3/4 of, it is 100. 3/4 of 100. And it falls also down and it continues like this. Next, it rebounds 3/4 of this one. 3/4 of, it fails. It fails 3/4 of 100 meter, or it is, when you simplify, 75 meter. This, it is 75. So it fails 75 meter. So on the next rebound, it rebounds 3/4 of 75. 3/4 of 75, or this result. So it goes on like this. It goes on like this. So we are asked to find the vertical distance, the total vertical distance traveled by this ball, 100 meter plus 75 meter, twice 75 meter, because it rebounds 75 and come down 75 meter. So twice 75 meter. Here also 3/4 of 75. It moves up 3/4 of 75. It moves down 3/4 of 75. So we have two distances here. We have two distances only. Single distance. We have single distance here. So writing this in summation form, you'll have this one. In the first falls, it is 100 meter, plus on the next fall, rebound is 75 meter. So we have 75 twice. Next to that, also we have it rebounds 3/4 of 75, but it moves up and down. We have two distances here, and so on and so on. So from this, you will have this one. The sum of these terms will be it is 100 plus this 75. It rebounds 75, falls 75 twice. Don't forget this one. On the next rebound also, it rebounds 3/4 75. It rebounds and falls so twice. This also distance twice. All are twice. Therefore, 100 is single numbers. It only falls down. Therefore, 100 plus twice of, when you see this term, it is a geometric sequence with first term 75, and the common ratio, it is 3/4. When you take the ratio of these two, you get 3/4. The ratio of these two, it is 3/4. So therefore, it is this one is a geometric series with first term 75 and the common ratio 3/4. I can find the infinite sum of these numbers. So 100 plus twice of this, it is G1 is 75 over 1 minus r. Infinite sum is given by, this is G1 over 1 minus r. So G1 is 75 over 1 minus the common ratio is this 3/4. Therefore, when you evaluate this, 100 plus twice of, when you simplify this, you get 300. So the final answer will be this 700 meters. So the total distance moved by the ball is this almost 700 meters. Now let's see one last example for this. Look this one. Here a ball is thrown vertically upward. In this case, it's not falling, it's moving up. A ball is thrown vertically upward to a maximum height of 100 meters above a flat surface, and it fails and bounces. So look this one. Let's take this, it's a flat surface, this is a flat surface. A ball is just thrown up. In this case, it's thrown up, it moves up and falls. The maximum height traveled here, it is given to be 100 meters. And then it rebounds. It rebounds 75% of the distance it fails. So it fails how much? It is 100 meters. So it rebounds 75% or 3/4 of 100. So it moves 3/4 of 100 up and down. On the next bounce, it rebounds 3/4 of the distance it fails. The distance it fails is, it is 3/4 of 100. 3/4 of 100, and it goes on like this. So you are asked to find the total distance traveled by this ball before coming to rest. So when you write the sum is equal to 100, it moves up and down twice of 100, plus here also it moves up 3/4 of 100, moves down 3/4 of 100, twice of 3/4 of 100, plus on the next one, that is twice, is also twice of 3/4 of 100, and it goes on like this. So plus it goes on like this. Therefore, to find the infinite sum, S infinite is equal to, you can take two outside, you will have this 100 plus the next term, it is 3/4 of 100, 3/4 of 100, plus on the next term this one, just we are factored out to 3/4 of 100, or 9/16 of 100, 9/16 of 100, plus it goes on like this. So when you see this, it's a geometric progression with the first term 100 and the common ratio is 3/4. Take the ratio of these two, take the ratio of these two, you get the common ratio to be 3/4. Therefore, the infinite sum, this is equal to this, is equal to twice of G1 is 100 over 1 minus R. Our R is 3 over 4 here. So the infinite sum is this one. Therefore, this is equal to 2y of or 200 times 1 over 200 times 1 over this is 1 minus 3 over 4 is equal to this 1 over 4. This is 1 over 4. So taking the reciprocal multiplying by 200, you get the answer. This result you get it is 800 meters. So the total distance traveled by this pole is almost 800 meters. So this is the answer. So the final answer is 800 meters. So this is all about today's lesson. So you can try these exercises by yourself. So until next class or next lecture class, goodbye.